A comet has just erupted near the Sun. In a single night, its brightness leapt beyond all predictions, its tail stretching wider than 5 full moons laid side by side. But what makes this moment even more extraordinary is what followed. The Sun itself unleashed its most powerful flare in months. A massive wave of energy blasting straight into the very region of space where Comet R2 Swan is now racing. 2 cosmic forces are now on a collision course, one forged from ancient ice and dust, the other from the raw fire of the Sun. What happens when these worlds collide? No one knows. Will the night sky blaze with brilliance, or vanish into silence? One thing is certain, the chain reaction has already begun. Comet R2 Swan, officially known as C 2025 R2 Swan, is now racing through the inner solar system on a path that brings it closer to Earth than ever before. At its nearest, it will sweep past at just 0.25 astronomical units, about 39 million kilometers, or 100 times the distance to the Moon. In cosmic terms, that is a razor-close flyby. Imagine a mountain of ice and dust, born in the frozen outskirts of the solar system, now hurtling past our planet's neighborhood at breathtaking speed. Astronomers call it a statistical rarity, but for us on Earth, it is a once-in-a-lifetime chance to witness a celestial traveler revealing its secrets under the unforgiving glare of the Sun. In mid-September, Comet R2 Swan began to change. At first, its light seemed routine. Magnitude 7.4, barely visible under dark skies. But then, without warning, the numbers shifted. Within days, it surged nearly a full magnitude brighter, climbing into naked eye territory. Astronomers knew this was no statistical blip. Outbursts like this point directly to the comet's nucleus. A frozen heart cracked by centuries of cosmic travel and now shattered by the Sun's relentless heat. Gas and dust burst outward, swelling the coma and feeding the tail. In a matter of hours, Swan transformed from a faint traveler into a living spectacle, a reminder that comets are built for surprise. By late September, Swan's tail had become a spectacle in its own right. Spanning more than 2.5 degrees across the night sky, it stretched farther than 5 full moons lined up, edge to edge. For skywatchers, that scale changes everything. This is no longer a faint smudge lost among the stars. It is a luminous scar across the heavens, demanding attention even from suburban skies. Within the glowing streak, knots of dust twist and shift, while the ion tail flickers electric blue, bending and rippling under the invisible force of the solar wind. As Swan brightened, the global astronomy community came alive. From Japan to Australia, from South Africa to Argentina, amateur skywatchers pointed their telescopes upward, capturing the comet's changing form night after night. Forums and online groups filled with stacked images, time-lapse sequences, and careful overlays that revealed how Swan's tail bent and rippled under the solar wind. For many, it was not just science, it was participation. Every photograph, every note taken, became a fragment of a global record, a living chronicle of a cosmic visitor passing by. On September 28th, the calm of the Sun was shattered at 8:43 UTC. A powerful M6.4 class solar flare erupted from a twisted sunspot region, releasing the strongest burst of energy in months. In its wake came a coronal mass ejection, a vast plume of plasma racing outward at nearly 900 kilometers per second, fast enough to cross the Earth-Sun distance in just 2 days. The flare was not Earth-directed, but its trajectory aimed straight toward the same quadrant of space now occupied by Comet R2 Swan, a cosmic arrow of fire heading for a fragile visitor of ice. When a coronal mass ejection meets the tail of a comet, the results can be spectacular. A comet's ion tail is not just made of dust, it is a stream of charged particles, a delicate ribbon of plasma stretching millions of kilometers behind the nucleus. As the CME sweeps across space, it drags with it twisted magnetic field lines. If those fields collide with the comet's tail, magnetic reconnection can occur, the cosmic equivalent of a giant circuit breaker snapping open. In just 90 minutes, an entire section of the tail can be cut off, severed from the comet, and left drifting as a glowing cloud. Spectral readings may suddenly shift, with hydrogen and oxygen lines racing by at 50 kilometers per second. For scientists, it is a rare chance to watch magnetic reconnection on a scale no laboratory can reproduce. For skywatchers, it could be a breathtaking moment the night when a comet's luminous tail is torn away before their very eyes, only to be reborn again. October 21st. 2025. The date has already been circled on calendars of astronomers around the world. On this night, Comet R2 Swan will make its closest approach to Earth just 0.25 astronomical units away, roughly 39 million kilometers. In cosmic terms, that is a hair's breadth. A near miss on the scale of the solar system. The timing could not be more perfect. On this exact night, the moon will turn new, leaving the skies darker than at any other point of the month. It means that Swan's luminous tail will stand out like a blazing scar across the heavens, unobscured by lunar glare. But Swan will not be alone. On this very date, interstellar visitor 3 I-Atlas reaches superior conjunction, perfectly aligned with the Sun from Earth's perspective. One comet from the icy depths of our solar system, another object from beyond the stars, both appearing within the same celestial corridor. Astronomers call this a statistical miracle, a convergence so rare that the odds of it happening in our lifetimes are almost non-existent. For humanity, this night could be unforgettable. The collision of cosmic timing, the brilliance of a comet in full display, and the silent presence of an interstellar wanderer watching from afar. It is not just astronomy, it is theatre on a universal stage for those who wish to witness Swan with their own eyes. Preparation will make all the difference. The comet will shine brightest in the southern skies, favouring observers in Australia, South Africa, and South America. But even in northern latitudes, patient skywatchers can catch its rise after midnight, climbing higher with each passing night. Finding it is easier than it sounds. Swan will drift near the constellation Piscis Austrinus. Close to Fomalhaut, the brightest star in the region, trace that beacon of light, and the comet's long tail will be waiting nearby. Equipment helps, but is not essential. A standard pair of 7x50 binoculars can reveal the full sweep of the tail, while small telescopes uncover its subtle twists and jets. Even a camera on a tripod, with just a few seconds of exposure, can capture Swan's glowing streak against the stars. This is not just passive watching, it is participation in a global experiment. Ich-Observation. Each photograph adds another piece to the puzzle, helping scientists and citizens alike track how Swan responds to the storm of the Sun. Across continents, teams of amateurs and professionals are already preparing for Swan's closest approach. From Buenos Aires to Perth, from Cape Town to Tokyo, observation groups are coordinating rise and set times, comparing charts, and sharing data in real time. For the first time in years, comet watching has become a true global campaign. Each observer contributes a fragment, a sketch of the tail, a photograph of its changing glow, a note of its shifting position against the stars. Together, these fragments form a living mosaic of Swan's journey. Scientists call this citizen science at its finest, the moment when humanity collectively documents a cosmic event, creating a record no single observatory could ever achieve alone. For the skywatchers themselves, it is more than science. It is belonging. To look up together is to realize we are part of the same story written across the night. As October 21st draws near, one truth remains: change is inevitable. Comets are unpredictable by nature, and Swan is already defying expectations. Its next transformation could unfold in minutes: a sudden kink in the tail, a burst of brightness, or even the shocking sight of the tail breaking away under the sun's assault. For scientists, the days ahead are a rare laboratory in the sky. For skywatchers, they are a chance to witness history, to see cosmic drama written live across the heavens. And yet, the ultimate outcome remains unknown. Will Swan's close passage ignite a spectacle never seen before? Or will the night remain eerily quiet, as if the cosmos guards its secrets for another age? One thing is certain: this story is not over. The chain reaction has begun, and the sky itself will write the next chapter